Bismillahirrahmanirrahim. Start with the name of Allah, who is the most beneficent and merciful, and durood on his last prophet, Hazrat Muhammad sallallahu alaihi wa alihi wasallam. This is class 9, chapter number 2. Binary system is the name of the chapter, and the topic that I will discuss today is memory and data storage, and some more topics that will follow it. So this is a long question, and it will ask in the text form that what is memory, and write a note on its types. If the examiner do not ask this question as a long question, then he can ask short questions. There are three short questions that the examiner can ask. The first one is, what is memory? The second one is, what is volatile memory? And the third one is, what is non-volatile memory? So first of all, here is the definition of memory. Computer memory is any physical device capable of storing data. Primarily, there are following two types of memory: volatile memory and non-volatile memory. So here the definition of memory is complete. Now, both type of computer memories, the definition of both type of memories are given below. First, the definition of volatile memory, which is also called primary memory and temporary memory, is as follows. A device that holds data as long as it has power supply connected to it is called volatile memory. Volatile memory, its best example is random access memory or RAM, which holds contents or data only as long as it has connected or it is connected to power source. You will write short question up till this line, and this last line will be written only when this question is attempted as a long. As soon as the power supply is disconnected, all the data in RAM is cleared or lost. The next part of this long question is, what is non-volatile memory? This question can also be asked as a short question. So non-volatile memory is also called secondary memory. A device which can hold data even if it is not connected to any power source, it is called non-volatile memory. The example for non-volatile memory is hard drive, flash drive, also called USB drives, and memory cards installed in cell phones. Up till this line you will write its answer as a short, and this line will be included only if you attempt this question as a long question. Even if you turn off your PC or mobile, your PC or you power off your mobile, the data in its card or hard disk will remains intact. The data in your hard drive or flash drive stays intact. Here's a figure of primary memory and secondary memory. Okay, next, how data is represented in computers memory. The first question is, how digital computers store data? So very easy. Digital computers store data in binary form. It means that whether it whether it is a text, picture, movie, or some application, it is stored in computer's memory in the form of zeros or ones. These two and a half lines will be written as the answer of short question. Next is the question, what is ASCII code or what is ASCII? All the characters on your keyboard has an associated code in binary. This code is called ASCII code of the character. ASCII stands for American Standard Code for Information Interchange. It is de facto standard. This line can be asked as an MCQ for representation of data inside computer's memory. I have already shown this table in an earlier video, so there are certain letters that you must remember that can be asked as an MCQ in the board exam. The first one is 32, that is the code of space. The second one is 48, that is a code of 0, and the third one is 65, that is a code of capital A, and then 97, that is a code of small a. After this, an example is given that write this text as a binary. So humans view about memory. Suppose we write Pakistan in by using keyboard. The ASCII code of each character is given here, and this and this code is converted into binary. So you will convert Pakistan by using its ASCII code into binary and then write it in a sequence. The next one is storage device. The next topic is storage device. So what is a storage device? Any computing hardware. Computing hardware refers to computer that is used for storing, porting, and extracting data is called storage device. It can hold or store information both temporarily and permanently. It can also be internal or external to a computer. These three lines will be the definition of storage device. Then there will be 2.5 lines as the answer of what is external device. So an external device, storage device, is a plug and play device that is plugged outside the computer. That is, we just plug it to some port and start using it without turning off the computer. For example, CD, USB, flash drive. These two are the examples of external storage device. From here you will start writing the answer of what is internal storage device. To the internal storage device is the one that is attached inside the computer. So its definition is as follows: to attach an internal storage device, hard disk or RAM, we need to turn off the computer. Internal storage devices are connected to some fixed slots on the motherboard. Examples are RAM and hard disk. So here is a table which describes the difference between memory and storage. 5 points are given. If you remember this piece of information, then you can write its opposite here. Storage device. So the first point is memory, place where an application loads its data during processing. And what is a storage device? Usually the place where data is stored for long or short term. Second point for memory is temporary storage device, and for storage is permanent storage device. Third point for memory is lesser in size, and for storage device is greater in size. Next point is high accessing speed, and the next point for storage is low accessing speed. And last point, it is called primary memory, and secondary memory is also it is called secondary memory. So here the next topic is measurement of size of computer memory. Here two short questions are given. The first one is what is bit, and the second one is what is byte. The difference of these two short terms can be asked in the question, so you can write these definitions. The smallest amount of data to be stored in computer's memory is a 0 or 1. It is called a bit. This is the definition of bit. A collection of 8 bits is called a byte. Then next comes the definition of byte. You can start it from here. A collection of 8 bits is called a byte. At least 1 byte is required to store any piece of information in a computer storage. The next line is MCQ. on both primary and secondary storage devices. Data is stored in the form of bytes. Bytes can be excluded from this text, and this line can be asked as an MCQ. Okay, from this table an MCQ can be asked in the exam. This is very important table from MCQ point of view. Bit, smallest unit of data, can hold only one value, 0 or 1. Byte, group of 8 bits, enough space to store a single ASCII character. Kilobyte, or 1 KB equal 1024 bytes. Byte is the smallest unit of memory from kilobyte. So the next one is megabyte, gigabyte, terabyte, petabyte. Here you can see that 1 MB, GB, TB, PB, and 1 MB equals to its smallest unit, 1024 KB. 1 GB equal to its smallest unit, 1024 MB, and 1 TB terabyte equal to 1024 of its smallest unit, that is GB, and 1 PB or petabyte equals to 1024 of its smallest unit, that is TB. Okay, from here you can see that 1 MB or 1024 KB equals 1024 raised to power 2 bytes, or 2 raised to power 10 bytes. Next, 1 GB or 1024 MB equals 1024 raised to power 3 bytes, or 2 raised to power 30 bytes. Uh, sorry, the 1 KB equal to 2 raised to power 10 bytes, 1 MB equal to 2 raised to power 20 bytes, 1 GB equal to 2 raised to power 30 bytes, and 1 TB or 1024 GB equals to 1024 raised to power 4 bytes, or 2 raised to power 40 bytes. And lastly, 1 petabyte equal to 1024 terabytes, or 1024 raised to power 5 bytes, or 2 raised to power 50 bytes. The next topic is the Boolean proposition. So its definition is as follows: a proposition is a sentence that can either be true or false. For example, the following sentences are propositions. Someone from our school can join Pakistani cricket team. I will get a plus grade in board exam. For short question, you can write any of 2 points from these 5 examples of propositions. I want to excel in mathematics this year. The Pakistan Super League final match will be played in Lahore. I play chess. Okay, after that, do you know? The piece of information in this box can be asked as an MCQ or short question. So here from this piece of information you can also write the definition of Boolean algebra, which is not given here in this topic. The Boolean algebra main heading is given, and then Boolean proposition is given. So I will speak the definition of Boolean algebra. Boolean algebra is the algebra of logic. It uses symbols to represent statements. Instead, it uses symbols to represent statements. True or false are called Boolean values. The idea was given by George Boole, 2 November 1815 to 8 December 1864. This is his date of birth and his day of died in his book The Laws of Thought. Okay, the next question is true values. Short question: every proposition takes one of 2 values, true or false, and these values are called the truth values. Truth value is given on the basis of truthfulness or falsity of a proposition. 2 examples of truth values are given in this book. Assume P equals to Islamabad is the capital of Pakistan. So this statement is true. You can assign a value of true on the basis of its truthfulness. Okay, so this proposition is true. The next one is Q equals to the sun rises in the west. This statement is false. The sun rises in the east. The truth value for this proposition is false. Okay, from here, long question starts, and logical operators is the heading of this long question, and this question can be asked also as a short question. Write a note on and operator, or operator, or not operator. If this question is not asked as a long question, then obviously one of these operators can be asked as a short question. So what is the definition of an operator? An operator is used to combine two or more propositions to make compound proposition. Okay, here's a definition of a compound proposition. Sometimes we assemble. Assemble means combine. Assemble more than one proposition to make one proposition called a compound proposition. For example, if we have the following two propositions: one, today is Monday; two, I am in school; then today is Monday and this is a logical operator, and we combine this and this proposition using this logical operator. And I am in school is a compound proposition. Truth value of the compound proposition depends upon the truth value of the individual propositions. This is a separate or individual proposition, and this is a separate or individual proposition. In order to the compound proposition to be true, both these individual proposition needs to be true, and the logical operator used to connect the propositions. In this example, and is a logical operator. In the following, we discuss three most commonly used logical operators: and, or, and not. The first one is and operator. Okay, so if we use and operator to connect two or more proposition, then the compound proposition is true only if all the connected propositions are true. And operator can also be denoted by a dot symbol. It means that P and Q may also be written as P dot Q. After that, you will draw its table that is not given in the book. It is on the next page. So you will write or draw this table. This table is for true propositions P and Q. The proposition P is it is raining, and proposition Q is today is Sunday. Then for different combinations of these propositions, their output values is shown, and the output value for AND operator is true only if both the propositions are true, otherwise it will be false. Okay. The next operator is OR operator. When we can also use OR operator to connect two or more propositions. Example given: today is Monday, or I am in school. In case of OR operator, the compound proposition is true if at least one proposition is true. These three lines will be written as an answer of short question. Then the remaining three lines will be the answer of long question. In other words, the compound proposition is false only if all the propositions are false. OR operator can also be denoted by a plus symbol. This line can be asked as an MCQ. It means that P or Q may also be written as P plus Q. After this, you will draw its table, which is given on the next page. So its table is as follows: P and Q. These are the different values of the propositions P and Q for these two propositions. It is raining and today is Sunday. So the proposition for this both the result for these both propositions is false only when both the propositions are false, otherwise this will be true. Okay, after that the last operator is not operator. The logical operator not is not a connector. What do you mean by connector? That is, does not connect two propositions. This operator does not connect two propositions, but it is used to negate a proposition. For example, if P equals today is Monday, then not P means today is not Monday. So with not operator, a true value becomes false and vice versa. Not operator can also be denoted by a symbol. Uh, it means that not P may also be written as not P. This piece of code can, this piece of line or text can also be asked as an MCQ, that which symbol is used to represent not operator. So you will write the long question, write a note on logical operators up till this line. After this, the next topic is a long question. If this topic is not asked as a long question, then uh, multiple short questions can be asked from this text. The first one is draw a truth table of AND operator, and the second one is draw a truth table for OR operator, and the third one is draw a truth table for NOT operator, and the last one is draw a truth table for the complex Boolean expression. So as a whole, these four questions will make up a long question. First of all, here's a definition of truth table. What is a truth table? A truth table is used to check whether a proposition is true or false. Usually, it is used to check the truth value of a proposition where some logical operator is used. In the following, we discuss the truth table for AND, OR, and NOT operator. So this is the definition of short question. What is truth table? Then the truth table for AND operator. Here is the definition of AND operator. What is the truth table of AND operator? Also draw its table. So you will write these lines from here to here. So its definition is the truth table for P and Q is given in table. The first two columns are showing all the possible combinations of truth values of propositions P and Q. The third column is showing the resultant truth value of P and Q. So the two propositions are as follows: P equal to it is raining, Q equal to today is Sunday. Then their compound proposition will be as follows: P and Q equal to it is raining and today is Sunday. Here this and will be represented as a capital letters A and D. Okay, if both P and Q are true, then the P and Q is also true. It means it is raining on Sunday. The situation is shown on row 1 of the table. So here is the table. Here the value of both the propositions are true. You will write each row of this table as a text. What will be the text for the second row? P equals it is raining. And for Q means false, that it is not Sunday. So here is the second proposition. Suppose it is raining. This value of proposition is true. Suppose it is raining but not on Sunday, then P is true and Q is false. P is true and Q is false. Then their resultant proposition will be false, and then for the third row you will write the statement as follow. Similarly, in row third of table, P is false. Here you can see P is false, and Q is true, it means it is not raining on Sunday. This third row, this it is not raining on Sunday, which results in false value of P and Q in the last row. This one, last row, the value of P is false and the value of Q is false. So you can write it as it is not raining and today is not Sunday, or it is not raining on Sunday. So the last line can be written is, in the last row both P and Q are false, which means it is neither raining nor Sunday. So the proposition it is raining and today is Sunday is false. This table, the four rows of this table are written as a paragraph of these lines. So you do not need to memorize it. If you know how to draw this table, then you can write this paragraph in your own words. Okay, let's look at the other table of OR operator. Here an MCQ can be asked that how many propositions can be formed from two propositions. So here is a simple formula. If there are two propositions, then 2 raised to power 2 equal to 4. 4 propositions can be formed from two propositions. These are two propositions, P and Q. So there are total 4 propositions which can be made from these two propositions. If there are 3 propositions, then 2 raised to power 3 equal to 2 into 2 into 3, 8. So if there are 3 propositions, then there are 8 different propositions that can be made by combining different values of these propositions. If there are 4 propositions, then 2 into 2 into 2 into 2, 16 different propositions can be formed. The next one is a truth table for OR operator. You have already seen the truth table of OR operator. From the table you can see that if the value of P and Q is false, value of P is false and value of Q is false, then the compound proposition will be false, else it will be true. So this piece of information is written here. For the same propositions P and Q, this P it is raining and Q today is Sunday. Let's see the truth table for expression P or Q. P or Q equal it is raining or it is Sunday. This compound proposition is false if it is not raining and today is not Sunday, otherwise it is true. So it is not raining and today is not Sunday. The compound proposition will be false, else it will be true. The next one is the truth table of not operator. And in this third row, in this third row, not p is true and q is true, so their final value is true. And in the last row, not p is true and q is false, so their final value will be false. So if we use AND operator to combine true or more propositions, then if the value of all the propositions are true, if the value of all the propositions is true, then the result of the propositions will be true, otherwise it will be false. That's all in this video. So in this video we have discussed uh, what is Boolean proposition, what are truth values, what is logical operator, a long question, and then what is truth table, a long question, and then truth table of a complex Boolean expression. Take a very good care of yourself, your near and dear ones, your parents, and may Allah bless you and shower His blessings on you and me also. Assalamu alaikum warahmatullahi wabarakatuh.